All right, go back to the directions at the beginning. It said that KN bisects LKM. Are we okay on if I name an angle, you can locate it on a diagram? Whether you follow the letters with your fingers or whatever method you have. We're okay identifying an angle. All right, next step is, what's this word bisects mean from Tuesday? Good, Ryan. Okay, cuts it in half, cuts the angle LKM into two congruent angles, and we had arc marks to represent that. So these two angles are the same measure. And in example 2, it said, all right, NKL 7x minus 9. And then it gave me this angle here, JKM, x plus 3. And we said on Tuesday, are those two angles right here congruent? No, they're not marked congruent. Nothing says they're congruent. Don't make them congruent. All right? What two angles are congruent? The ones we marked with the arc marks. So if that's 7x minus 9, what's the one over here? Hey, 7x minus 9. Now, is it going to make sense for me to go 7x minus 9 equals 7x minus 9? Good luck solving that. Let me know what you get. Okay? When the x's cancel out. Negative 9 equals negative 9. All right? That's not going to get you anywhere. But that's why they gave you this fact right here, that KJ and KL are opposite rays. Opposite rays, if you remember, if you go back and look, I don't want you to, but they're collinear, which means this is a line. And what type of, it's called a straight angle, but what's its measure? 180. So you know all three angles up here, x plus 3, the 7x minus 9, and the other 7x minus 9, because it forms a straight angle, equals to 180 degrees. And then we solved, and so we can just get going. I think I gave you the answer here. X turned out to be 13, but we were looking for JKN. JKN. Take a look. How would you find JKN now that I know X is 13? Now that I know X is 13, how could you locate JKN? Okay, here you go. 28. How can I locate JKN now? Well, I already did that. I solved for X. And then plug in what for X? 13. And then we should get angle JKN. What did I say on Tuesday? 98. 98 degrees. Okay? Everyone all right before we get to the last one and then the homework? All right, next one. Can you draw me that diagram? No diagram here, you need to draw it. Draw angle BAC such that AX is an angle bisector. So let me see you draw angle BAC, bisector AX, and make sure it's got the correct markings on it for me, please. Remember when they name 3 letters, an angle by 3 letters, what's the middle letter? Well, in this case, I know it's A, but what's that referring to? The vertex. That's where the 2 rays meet. Yes. Good. Make sure we got arc marks showing me what 2 angles are congruent since we're talking about a bisector. Okay, so we got the diagram down. BAC being cut in half. And then we have BAX being 5x minus 25. And then CAX being 3x plus 5. And we're looking for the values of X and BAX. So go right ahead. See what you can do on your own there. Set up an equation to solve for X. And then go back, use X, plug it in. Plug it back in to find BAX. I'll ask a couple people what they ended up with in a second. Okay, first thing I'm going to ask somebody is the equation you're solving for x. Equation you're going to use to solve for x. Here you go, it's 27, the equation you're using to solve for x. You got it. When you're ready, let me know the value of x. When you're ready, let me know the value of x, 6 when you're ready. What is it? 15, yep. And then we plug it in to find angle BAX. So we're going to go 5 times 15 minus 25. And BAX comes out to be, whenever you're ready, 5 whenever you're ready. $50 degrees, got it. All right, everyone, all right, the term bisector. Questions? Ask them now. Okay, let's go to the homework you had. Had a couple days to do this homework. Let's get it going here. Let's ask questions. Where are we going? All right, start us off. 41, okay, here we go with 41. First thing, I want to just turn your attention to the diagram. Do you see what was already marked for you? 2 congruent angles. That is different than what they're telling me here. Okay, they never said that these 2 angles were congruent, but they are marked, so they're congruent. So hopefully you noticed that while you were doing the work the last couple nights. But they do say BH bisects EBC. Ready? EBC, and BH is bisecting it. So that means HBC has to be congruent to EBH, because BH bisecting EBC. Everybody good? I noticed I did 2 arc marks because the ones were already being used. We okay on that fact? 41 you said, correct? Okay, 41, let's see what my angles are. ABF, let's see, ABF, that whole angle right there, 8s minus 6, so I'll just do this. So you know what I'm talking about. And then ABE, let's see, ABE, that one right in the middle is 2 times s plus 11. Find EBF. Okay, what did I know from the markings from the very beginning? Congruent. So it means if that angle right there they gave me was 2 times, and this might have freaked people out, I don't know, 2s plus 11. What's the other angle? 2 times s plus 11, because they marked that they were congruent. And I was told that the whole angle, when I add those 2 together, was equal to 8s minus 6. Okay, and all I need to do here, I don't know if this algebra freaked anybody out, but just distribute. 2s plus 22 plus 2s plus 22 equals 8s minus 6. I'm going to solve for s. It asked me for EBF, so I'm going to just plug it into 2 times s plus 11 and solve. We okay? All right. Any more here? Any more? Yep. 42. Get rid of my, actually, I don't want to get rid of my whole markings because those are still congruent, so let me get rid of this. Okay, let's see what they gave me for 42, everybody. 42, EBC. So EBC. So I'm going to go from here all the way over there. That's a big angle. 3r plus 10. And then I'm going to go ABE, this angle right here, 2r minus 20. Find EBF. Okay. All right, ready? Are these two angles congruent that they gave me? Absolutely not. Okay, so don't set them equal. But I got to do something with them, right? BA and BC are opposite rays, meaning what type of angle is ABC? That's a straight angle. What do straight angles add up to? 180. And don't you agree if I take this angle, the 3r plus 10, and 2r minus 20, aren't I going to get the straight angle? Everyone agree? If I add those two angles together, I'm going to get ABC, the straight angle. So that's exactly what I'll do. 2r minus 20 plus 3r plus 10 equals 180. I'm going to solve for r. I'll do that right now. 5r minus 10 equals 180. 5r equals 190. R equals, let's see, that's going to be a 3, 4, 38. Now it's looking for EBF. Any thoughts on how I could find EBF? Because they didn't give me anything to plug in an expression for it. Any thoughts how I can use the 38 to solve for this angle right here, EBF? Because they didn't give me something with an R in it that I can simply just plug in. Go ahead, Meg.
Well, angle ABE is congruent to angle EBF.
Okay, yep. So if that's 2r minus 20, this also has to be.
2r minus 20.
So
If you solve that, then you should.
there you go. Yep. I'll just plug in. Good. Other questions, comments, concerns? More questions you have. Let's get them all done now. Because now hopefully you're starting to see it's becoming a little bit more challenging from time to time. Nothing else in the book? Not just these questions, but just any questions in the book. I knew these questions were going to be asked, so that's why I just copied and pasted before you came in. Nothing else? Okay, let me see your work quick. And then we're still playing with angles today. Tomorrow. All right, let's roll. First type, adjacent angles. When you guys hear the word adjacent, any other word associated with it come to mind? Next to? All right, something's adjacent, they're next to each other. All right, well, that's kind of true for adjacent angles, all right? But they have to have a common vertex and share a common side, all right? And I'll get into this in a second. They do not have any interior points in common. All right, take a look at example A. I'm going to go through each one of these with you. Take a look at example A. Are X and Y adjacent to each other? Here's the test. Here is the test. Do they share a common vertex? Absolutely, this one right here. Do they share a common side? Yeah, everyone see that ray right there. And here's what I'm talking about. They do not have any interior points in common. Ready? Put an interior point right now somewhere in angle X. Put a point somewhere inside angle X. Is that point also in angle Y? Can you guys have a point that's in both? Is it possible? Okay, if it's not possible, then yes, these are adjacent angles. Because they share a ray. What do you think about example B? Do you think those are adjacent? Maggie, what do you got?
They're not.
Okay, hold on. So you're saying a no. So I'm listening to why it's a no. Go ahead. Absolutely. Everybody see, here's the vertex for Y. Here's the vertex for X. They do not share the same vertex. Excellent. So no, they do not have a common vertex. Okay, C, just so you know, angle Y is this angle right here. I don't know why they put a big circle there, but angle Y is this angle. Angle X is that angle right. No, it's just no. I don't know. It just this is the angle. This is angle Y, and this is angle X. So there's no need for the bottom. Do we think they're adjacent or not adjacent? Making sure. Go ahead, Catherine. Okay, where? Put a point somewhere where it's in X and Y. This one right here? Okay, but that's not inside. If I put a point on there, that's not considered inside. Inside would be right here, somewhere actually inside the angle. What you just described to me, though, is a ray that they both share. So they share a ray. Do they share a vertex? Okay, are there any points I can put inside that are in both? No, so they're adjacent? Yes, they are. And again, you can just put they share a ray. Okay, before you make a decision on part D, just let me explain to you what the heck you're looking at here. Angle X is the entire angle. Angle Y is this one right here. So let me highlight it. Angle X is what I'm putting in brown right now. All right, and angle Y is what I'm putting on neon green right now. Okay, let's go down the checklist. Do they have a common vertex? Okay, they do. I 100% agree. Do they have a common side? Yeah, right here, right? Where the green and my green and brown overlap. And the final thing you have to check, do they have any interior points in common? Unfortunately, they do, right? Here you go, ready? Everyone agree that's in Y and in X? So if they have any interior points in common, adjacent or not adjacent? They are not adjacent. Yep, they have interior points in common. Bless you. Everyone see that? What I mean by interior points in common now. They won't be adjacent if they do. Questions from you guys? Okay, you guys have heard of these before, right? Complementary angles, two angles. Can you do me a favor here? Because I don't know if you ever knew this before. Underline 2. It's got to be 2. Well, what about if you have 3 angles that add to 90? You know what I call that? 3 angles that add to 90. Okay, I don't call them complementary unless there's 2. Fun fact for today. All right, so here you go. Let's get a little quick diagram. Let's say that's 40 degrees. And let's make another angle. That's going to be, oh boy, 50. That's the old middle school, elementary school way of seeing complementary. You ready for the honors high school way now? You're going to start seeing it. 2 complementary angles. And that's not 1 degree and 2 degrees. That's just angle 1 and 2. How do I know those 2 add to 90? Go ahead. The little box. And from Tuesday, what the little box mean? Katie, what the little box mean? It's 90 degrees. All right, everyone agreed? This is how you're going to see complementary angles now. All right. I know they add to 90 because of the symbol. And give me another name for them. Not only are they complementary, they're also, just talked about it, they're also adjacent. There we go. Everybody good? Supplementary, 2 angles that add to $1.80. All right, let's go over the elementary middle school way of seeing this. 2 separate angles. And yes, it's still got to be 2. So let me give you a 120-degree angle. And I'm almost cringing asking you about this one. This should be a 60-degree angle. Good. That's the way we used to see it in elementary and middle school. Now, what you're going to see here is How do I know they add up to 180? Well, I'm going to tell you that's a line. How about that? All right, that's a line right there. How do I know they add up to 180? A line's another name for what type of angle? A straight angle measures 180. Also, what type of angles are 1 and 2 other than supplementary now? They're also adjacent. Look at that. All right. Now, let's put this adjacent concept and supplementary concept together. If you have two angles that are adjacent and supplementary, they form a straight line. Two angles that are adjacent and supplementary, we call them, this may be a new term for you, everybody take a look, linear pairs. Two angles they have to be adjacent. Hey, take a look up here. These two right here, do they add to 180? Are they adjacent? No, I don't refer to them as a linear pair then. What about these two? Do they add to 180? Are they adjacent? Okay, so they are linear pairs. And also, here you go. The word linear has what word in it? Line. So it's got to form a line. Two angles that form a line. What do we think about A? Are angles 1 and 2 a linear pair? Well, they're adjacent, aren't they? But they don't add up to 180. Yes, thank you. So this is no, don't add up to 180. How about B? Yeah? Everyone agree? They add up. I'm going to assume that this is a line. Adjacent, add up to 180. Yes. What about C? Linear pairs? They're not adjacent, are they? Because why? They're not adjacent because do they have the same vertex? No, they do not. All right, so this is no, they're not adjacent. Okay, your first time here. Theorem. Probably the most famous one you guys know is Pythagorean theorem, all right? Theorems are facts in math that can be proven, all right? We're going to write our first geometrical fact of the year. This is a big moment for you and involves linear pairs, all right? Linear pairs, and we're going to use this one throughout the year. What do you know about linear pairs? There's two things you know. One of them is going to be in the theorem. The other one's not. Linear pairs are adjacent. Okay, I'm not going to write that, but they also are supplementary. That's your theorem. Linear pairs are supplementary. A fact in math that can be proven. So it can be proven true that they're supplementary. Have you ever heard of these before? Vertical angles? Vertical angles? Verts, as I like to call them. Vertical angles, yes, no? Okay, but here's what are vertical angles. Two intersecting lines are formed. All right, two intersecting lines, the angles that are opposite. All right, so if I just do a quick sketch down here, vertical angles. How many angles did I just form right now? 4 of them, right? Everyone agree? I formed 4. 1 and 3 are vertical. 4 and 2 are vertical. The ones that are opposite each other when I have two intersecting lines. Give me a name for 1 and 2. Oh, more big boy, big girl time. Come on, we just got a term. Linear pairs, yeah. What are 4 and 2 called? Vertical. 4 and 3. Okay, we're good. All right. So before I give you the special fact about vertical angles, diagram A, are those vertical? No, but they are linear pairs. Yep. How about B? A lot of people say yes because you're like, oh, they're opposite each other. We're good. But they're only opposite when the two lines intersect. Lines, are those lines? No, maybe one is, definitely not the other one. All right, just because they're opposite doesn't make them vertical. It has to be formed by two intersecting lines. And how about C? Yes, those are vertical angles. All right, what's so special about them that they have to have a theorem? You guys are going to find out for me. And this is not drawn to scale. 28, just give me a random degree measure for angle 1. 30? Okay, help me out, guys. If that's 30, name another angle that's 30. Actually, you don't know this yet. This is the fact that's coming. What's angle 2 then? 150. Give me reasoning. Because they are? Oh, because they are? Okay, we're just yelling out vocab now. All right. These two are what type of angles? Linear pairs. And now what do you know about linear pairs? They are? So that's got to be 150. Keep going around the board with me here. What type of angles are these? Linear pairs, so they're supplementary. So what's the angle measure here? And one more, what's angle 4? What do you know about vertical angles? And give me a vocabulary term we've been talking about. I don't want to hear the word equal anymore, please. All right, let's actually get something here. Connor, go ahead. They are congruent, and that is your theorem in there. Vertical angles are... Oh, I forgot to tell you. Pet peeve here, math. Have some self-respect when you spell the word vertical. It is not verticle. Okay? It's not like barnacle. All right? Vertical. It's cal, everybody. Self-respect. Get some. All right? Vertical angles are congruent. And you'll start noticing here, I'm going shorthand anytime I can. Okay? Anytime I can go symbols, I'm going symbols. Right? Vertical, self-respect, right? Get it, get it. Any questions so far? So we have linear pairs, and then we have vertical angles. Anything from you guys? Well, here we go. Ready? What's it going to be? Hurry it up. We possibly could have no homework here. Promethean man or what? Guess the slide. This is huge. Okay, I got a curl here. Other nominations before we vote. Shatter. Ooh, that's a good one. Curtains. Slide right. Okay, sure. Slide left. I don't have no idea what that is. Cube. Pinwheel. Star. But you're going to vote for one, though. Yeah, you vote for one. It's just because it comes up one. No, that's not how we roll here, guys. That is not how we roll. Pinwheels? Yep, that's pinwheel. Okay, let's vote. How many? So you choose what you think is going to be next. I go with the majority, and if it is, we get no homework. Or if it's the Promethean man again, no homework. Okay? Curl. How many think it's going to be curl? Got 2 curls. Shatters. 1, 2, 3, 4, 5, 6, 7, 8 shatters. Curtains. Slide right. Only vote once. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Slide rights. Slide lefts. I got 2 slide lefts. Cubes. Got 1 cube. Pinwheel. 2 pinwheels. And a star. Okay, so it's got to go slide to the right. Everybody good? Slide to the right. A slide. All right, slide to the right. Or Promethean man again equals no homework. Everybody good? The best part of this is it's not going to be either. All right, but it's going to be something up here somebody didn't vote for, and that's the best part. Okay, and the kid's like, I told you so. Okay, suspense is building. Everyone ready? Slide right or Promethean man? Everyone ready? Ooh, cube. Cube it was. Nice. Cube it was. All right, going back. Going back. Going back. All right. Woo. Who had cube? Who had cube? There we go. Who had cube? There it is. All right. Hey, it happens. Livens up class a little bit. All right, perpendicular lines. Two lines that intersect to form right angles. All right, so let's get two lines. And these could be, I say lines, everyone, but it could be segments, could be rays. We've talked on Tuesday what marking should be on your diagram if it does form a right angle. A little box, right? Now, what's that? Box. There might be. I've never heard of one, but box. There is a symbol for perpendicular I'd like you to get used to now, so we don't have to write the word perpendicular every time. So if I want to say line AB is perpendicular to line CD, anybody know that symbol I would put in between for perpendicular? Have you ever seen this symbol? The upside down capital T. Okay, there's the symbol for perpendicular. We're going to use that a lot. Questions from you guys here? Questions so far? Okay, I want to get to some of the word let's see, where are we here? So I don't run out of time here. Two angles, complementary. Because I want to give you guys a little bit of time to try some of this stuff. Okay, go to example 5 for me. Go to example 5. Right off the bat, it says two angles are complementary. So what do I know about these two angles? They add to, be careful, 90. All right, so I always like to say, all right, I got two angles, and they're going to add to 90. Now I just got to fill in what those angles are. Okay, if you want to do it this way, that's fine. If not, it's fine too, if you have a different way. But I have two angles, angle 1 and angle 2, that add to 90. All right, what do I know about these angles? The degree measure of the smaller one is 50 less than the degree measure of the larger. Usually I start all these problems off by at least calling one of the angles x, okay? And then building off of that. So I know one of the angles is x. How does the other one compare to that? Well, it's small, 50 less than the larger one, which I just called x here. So how do I write 50 less than that? X minus 50. Now, I'm not going to require it here because it's not needed on the rigids. I don't need let statements. Maybe that was a big thing last year in algebra. All right. But keep in mind, which one's the larger, which one's the smaller up here? X is my larger, and x minus 50 is my smaller. Okay. Now, could I have called the smaller one x? Yes, but what I would have called the larger one then? X plus 50, okay? So there are different ways to go about it. And then we're okay solving this. 2x minus 50 equals 90. 2x equals, let's see, what do we got, 140? X equals 70. Go back, guys, reread the question for me. What am I asking for? Degree measure of the larger angle. What did we call the larger angle? Okay, we're done. 70 degrees. And then I'll do this last one with you here, 6. What do I have now? Two angles are supplementary, so they'll add to. Okay, so I got two angles that are going to add to 180. That's the definition of supplementary. Ooh, this might be new for you. They're in a ratio of 7 to 2. They're in a ratio of 7 to 2. So could we just start guessing and checking and being like, oh, 7 degrees and 2 degrees. Can't be those. Why? They don't add to 180. Could it be 14 and 4? Nope. Could it be 21 and 6? No, right? Do we want to keep doing this, though? No. All right. I don't want to keep, who knows when I'm going to hit the target. So instead, everyone see the ratio of 7 to 2. Anytime I have two numbers on a ratio, I'm going to put x's with them. I'm going to figure out what x is, plug it back in to find out what combination worked. Okay? What combination? So I don't have to keep guessing and checking, guessing and checking, guessing and checking. So anytime I have two numbers in a ratio, I'm going to add them together and put x. Well, not add them, but I'm going to put x's with them. So this turns out to be 9x equals 180. What's the value of x? 20. Does that mean one of the angles is 20, though? No. All right, I have to go back and plug and chug. So the smaller angle, where am I going to plug 20 in to find the smaller angle? Into 2x, so 2 times 20, 140. 40. And then the larger one you're going to plug into 7x, so 7 times 20, 140. And hey, quick check. What do you notice about 40 and 140? They add up to 180, so they have to be supplementary. Okay, and no, you don't have to finish the rest of it. All right, there is bookwork tonight, though. Yeah, not too bad. All right, come on in here if you guys want to start getting some extra help on stuff. Nice job today. Compass tomorrow.